Solve the following logarithmic equation. Log of x plus log of x minus 21 equals log of 100. So there's no base written in here, and when there's no base written in on your logarithms, it's understood to be base 10, which is a common logarithm. And what's nice here is that since everything has a logarithm attached to it, we might not even need that fact at all. Because if we can get two logarithms set equal to one another, then we can really just drop those logarithms and continue solving. So log of x plus log of x minus 21, since these two are added together and are of the same base, we can combine that into log of x times x minus 21. And then that's, of course, still equal to log of 100. Now, the next step is to effectively drop the logarithms, but that's not exactly what's going on. What's really happening is we're raising both sides of the equation, making them an exponent with base 10. So that matches the base of the logarithms. And then there's a property that something like 10 to the log base 10 of anything is just whatever that anything is. So the logarithm and the exponential cancel at that point. But you don't really need to know that as long as you understand what's going to happen next, which is effectively that the logarithms get dropped. Then that's perfectly fine. Next up, getting x by itself, it looks like I'm going to have a quadratic because when I distribute this x times x is x squared, x times negative 21 is negative 21x, and then I have that equal to 100. But because of that quadratic term, what I need to do is get everything to one side of the equation. So I'm just going to subtract 100 from both sides, and hopefully it will factor. We'll see. So x and x are the only things that will multiply to x squared. For 100, let's see, I think maybe I could get 25 and 4 to work, because those certainly multiply to 100, and if 25 is negative, 4 is positive, they would also add up to negative 21. So they multiply to negative 100, add up to negative 21. So this is great. So that means my solutions come from x minus 25 equals 0, or x plus 4 equals 0. So x equals 25, and x equals negative 4. Now, at this point, these are only potential solutions. We don't know for certain if they're solutions to the original problem or not until we plug them into the original logarithms. So you need to take each value and plug it into the original equation. So this would be log of 25, because I'm just replacing x with this number, plus log of 25 minus 21. And since that's equal to 4, which is a positive number, that's perfectly fine. So the arguments on both of these logarithms are positives, so that works out as an actual solution. When I try negative 4, however, this would give me log of negative 4 plus log of negative 4 minus 21. So log of negative 4, since that's the logarithm of a negative value, that's enough to say that this is not a solution to the original problem. So we need to throw that out, but we will keep the solution 25.